Good morning, students. And today's topic is the induced stresses developed in the mining. What are the different induced stresses which are developed in the mining? In the last class, we discussed different stresses which are developed, um, in the mining. Uh, those are nothing but the the weight stresses, inherent stresses, the residual stresses, and the induced stresses. And the weight stresses are, and there the two stresses are there, where vertical stresses are there, the lateral stresses are there. The vertical stresses are by virtue of the weight, by virtue of the gravity of the acceleration due to gravity, and the vertical stresses are created, the vertical stresses are developed. And the lateral stresses are there. These are the two types of lateral stresses are there. Those are lateral lithostatic stresses, which are developed by the surrounding rock. Actually, the existing mineral bed is it. The mineral bed is subjected to surrounding one, and the subjective pressure is called lateral lithostatic pressure, which is acting very horizontally. In the similar manner, second one is lateral hydrostatic the stresses, and strata, and the mineral bed which is subjected to hydraulic pressure, and the hydraulic pressure is given by the surrounding surrounding water bearing strata. It is there. So these are the weight stresses which are developed in this in the strata. And then similarly, and there are inherent stresses are there. Inherent stresses by virtue of the strata itself in the earth, in the ground, in the crustal part of the earth, the stresses are developed. These are the geological stresses. What we can say in the mining term, the geological disturbances. Uh, with the geological disturbances, many stresses are induced in the mining, and those geological stresses are the folding, the jointing, unconformities, and the fracture. These are the different geological structures, different geological disturbances, which are very much considered in the mining. The faulting, and these are the different things are there. And in a similar manner, and the faulting is due to the dislocation of the strata. The folding is when the strata is subjected to subjected to the forces, the compressive forces, then the folding it is occurred. And in a similar way, the jointing is done due to the cleavage of the mineral bed. The jointing is done, and the fracture and the conformities. And unconformity is the superimposition of old and new the rocks, where some part of old and new rocks are eroded, and become very weak. So this is the unconformity. And the fracture also, it is there, and it has got a regular pattern, a conchoidal pattern, a constant different types of fractures are there. The mineral bed has a tendency to get a fracture in the similar pattern. So these are the different geological what we can say geological structures, the geological disturbances which occur, and the stresses are occurred due to this. Out of all these things, the faulting is major geological disturbances in the field of mining. And while excavation is being made, while we are advancing, the when we come across with the fault, so the mining is stopped. Why? Because the strata is disturbed, very much disturbed. Why? Because the part of strata is lifted, goes upward, and some part of strata goes down. So there the continuity of the mineral disappears, and so there the mining is stopped. And after uh, reaching after reaching this one the fault, then we start the mining after overcoming the fault. Where the faulting is there, in the faulting area, the area is very much the weakened and very much weakened form, and the mining in the faulty area becoming very dangerous and very risk. The mining is impossible, sir. So these are the inherent stresses. In a similar fashion, residual stresses are there. The residual stresses which are induced, uh, maybe by the blasting, and maybe by the other excavations. So, but the rock retains some type of energies in the form of strain energy. It retains the energy, and those energies are called residual energies. So these are the different stresses which are developed. The final one is the induced stresses. Actually, we can define the stress is the stress is nothing but it is a force acting upon a block, upon a block, where the rock block is subjected to deformation, subjected to elastic and plastic deformations, is called the stress. And the stress is in a physical quantity we can define like that. It is the ratio between the force and the area, where the force is nothing but the force is the stress. Stress is force into acceleration due to gravity, where physical F G. The force by unit area is called force by unit area, where the force is m into acceleration due to gravity by unit area, m into g equal to, this is smart base, that is kgs meter per second square into 1 by a. A means meter square, then it becomes kg meter into second square. The unit of, so the ratio of the stress is the force per unit area, where the force is the mass into acceleration due to gravity. The mass equal to the mass is in kgs. The unit of the mass is kgs, where the unit of g is meter per second square. Meter per square, that is mostly 9.8. And finally the force may be, the unit of the force is the newtons, and the unit area is called 1 by a. 1 by a means area of a cross section of some rock block. It is there. So meter into meter equal to meter square. Then final, the stress, the unit of the stress is kg per meter into second square. It is there. So the stress which is defined like this, it is the ratio between the force and the unit area of the rock specimen. So we define the stresses like that. So what is meant by induced stress? The induced stress is nothing but the stresses are which are induced. Actually, the induced means we are creating that, but in the mining field, the different things are there which are related to the stresses. Suppose the different excavations are made in the mining field, and the blasting is done, and the different types of minings are there. A lot of mining is there. In the mining, blasting, the conventional mining is there, and the mechanized mining is there. In conventional mining, drilling, blasting, loading, transportation are the different phases of the mining, where the drilling and blasting is done. And the blasting, due to the blasting, the stresses are the overlying strata and the strata surrounded surrounding this one um, actual coal is subjected to stresses, and those stresses are called the induced stresses. So even in the mechanized mining also, the shearer is there. The capacity of the shearer is nearly 1100 HP, but while excavating and the outside strata is subjected to many stresses. The outside strata is subjected to the severe and the serious stresses, and these are called induced stresses. So we will discuss, and we will discuss in the class where what are the things where how the stresses are developed by the blasting, how the stresses are developed in the mining field, in the working area. So many things are there, and we will discuss one by one. Where when you see one by one, and from conventional mining to conventional mining to, and this one what we can call from mechanized mining. Many minings are there. Maybe UZ mining, maybe the underground mining, maybe the open testing, whatever it is there. So in all the fields, the blasting is done, then excavation is done. So when you see the conventional mining, board and pillar mining is there. In the board and pillar mining, two things are there, where development work is going on and the deep work is going on. In the development work, what we do, we convert the actual block of the coal into different uh, different pillars, and actually the size of the pillar maybe varies from 26 meters to 48 meters as per the CMR 1957. 26 meters into 26 meters into 3 meters. The size of the pillar is. So 26 meters into 26 meters is actually 26 meters into 26 meters into the 3 meters, and up to 48 meters into 48 meters into in 3 meters. So whereas this 3 meters is the height of the this thing, thickness of the seam, or height of the seam. Generally, the mining is done. Actually, where board and pillar is done, the height of the thickness of the seam must be 3 meters. Even 5 meters coal is available, but up to 3 meters only we excavate. Remaining coal is left in the roof, that is there. So, but when you want to excavate more than the 3 meters or the 4 meters are special, the special permission is taken from the director DGMS, Director General of Mine Safety, is there. So the general mining is possible. General mining is allowed for removing the beds having a thickness of 3 meters only. So is 26 meters and 26 is the side of the square pillar. Actually, the pillars are in the form of maybe in the form of a square pillars or rectangular pillars are formed in the development. So the side of the pillar is 26 meters and 26 meters. So these are, and it varies from 26 meters to 48 meters. So this is about the development where the work is going on there. So different pillars are there. So how the pillars are developed by driving the dip galleys, by driving the raised galleys, by driving the level galleys. Also all the galleries are developed, and due to development of all the galleries, the pillars are formed, and this is called board and pillar mining, where the development work, where the board and pillar mining and development work, what we can say, where the pillars are formed. In the development work, the drilling, blasting, loading, transportation are the different phases of the mining. The different phases of mining, where drilling is actually small scale drilling is here done here. Why? Because the UZ conventional mining very easy, where solid blasting pattern is there. In the solid blasting pattern, up to 12 to 25 holes are drilled, and the size of the hole around 32 mm, and the depth of the hole 1.2 meters, something like that. So very small holes. When we see the OC holes are very much bigger compared to the UG holes. So the length of the hole is 1.2 meters around, and slightly it is having an angle and 45 degrees to 75 degrees, and the dia of the hole is 30 to 35 mm. It is there. So the holes are drilled. While drilling the holes, they around the surrounding strata is somewhat this one somewhat affected. So and it creates some stresses while drilling also. It is there. So these type of stresses is, as given by the as exerted by the drilling. This is what we call this one conventional mining. And in the conventional mining is the second phase of conventional mining, the blasting. And where the blasting actually, the suppose for 25 drill holes are drilled. In the 25 drill holes, the with the explosive, all the 25 drills are charged. All the 25 drill holes shots are charged with the explosive, and the solid blasting having 25 holes are is blasted out, is where the blasting is done. Then by putting solid Ajax G, and pentadiene and the different explosive underground used permitted explosive P5 explosive is there. The P5 explosive Ajax G, solid Ajax G, pentadiene, different explosives are there. All the explosives which are charged in this one and blasted out. So the blasting is done. So while blasting, not only the coal is excavated, the surrounding part is also disturbed. So the surrounding part is subjected to different stresses. Those stresses are called induced stress. These induced stresses are very much dangerous, and the freshly exposed roof, when the blasting is done, the roof is exposed very much freshly, that we call freshly exposed roof. The freshly exposed roof needed much supporting. So when strata is outside, strata is very much affected. This one, the what we say, the surrounding one is affected, and we should be very much be taking care of all these things. That is it. So this is about the drilling operation. And the second side, this is about the development where the drilling operation is. And the next one is deep layering operation. In the deep layering operations, where the removal of the pillar and excavation of the pillar is called deep layering operations. So the pillars are there, and the pillars and the size of the pillar varies 26 meters to 48 meters. Suppose if we take 48 meters, and the different sizings are there. Actually, maybe it may be the pillar size of pillar size may be there. Actually, how it will becomes like this. A 4 meters or 2 meters grid part is left, and this one 4 meter slicing is the removed, like that. Anyway, suppose the 40 meters or the 48 meters the pillar is there. The pillar is converted into number of stoops. Suppose suppose a 40 meter is there. The 40 meter pillar is converted into 2 stoops, and the 2 stoops means and the slicing may be 4 meters. So when you remove the 4 meters, 40 meters minus 4 meters, it becomes 36 meter. 36 meter by 2, it becomes 80 meters. So and this is how we become, and this is and 18 meters and 18 meters, this is, and this is 4 meters. Total it becomes to 40 meters. 40 meters, 18 meters, how it becomes. So first rib, maybe 2 meters. Suppose if you do 2 meters and 4 meters, 4 meters and 4 meters, and the 8 meters, 12 meters, and again and 4 meters is there. So the rib is the 2 meters rib is left out, and the four slicing of are taken out. The first slice is 4 meters, and the second slice is 4 meters, third slice is 4 meters, 4 meters, like that. 4 slices, 4 meters into 4, 4 16 meters, 16 plus 2, which is total 18 meters. So the length of the stoop is 18 meters. The two stoops are formed in a pillar. So when 4 meter vertical slice is made, the 4 meters vertical slice converted the pillar, 40 meters pillar into two stoops, and the length of the width of the length of the actual stoop is 18 meters. The 18 meters is excavated by leaving 2 meters rib. The 2 meters rib which is left out for the supporting purpose, and the 16 meters converted into 4 slices. The first slice is taken out, second slice is taken out, and third slice is excavated, fourth slice is excavated. Similarly, all 4 slices are excavated, and finally after that they come to the rib part. The rib is also excavated. The rib is judicially excavated. Why? Because when the roof is very big, then the rib is left out. When the roof is very strong, then the 2 meters rib is also excavated. The 2 meters rib is also taken away. That is there. So like that, 80 meters of the slicing is taken. So slicing, while slicing, what we do? The blasting is done. While slicing, heavy blasting is done. But in the development work, only the galleries are developed. The deep galleries develop, and rise galleries develop, and the level galleries are developed. But in the deep layering, why? Because the 40 meters pillar is removed, and a number of conversions are made, convert into the stoops, and the stoops are excavated uh, by the slicing operations. So the slicing operations and the stoop formations, with all these operations, the total 40 meters into 40 meters into 3 meters, the dimension of the pillar, general pillar, the optimum pillar in the single college is 40 meters. 40 meters into 40 meters into 3 meters is the dimension of the pillar that is taken out by the slicing. Here, heavy blasting, while removing the slicing, 4 meter slicing, heavy blasting is done. The heavy blasting which create a number of which create many stresses to the strata, to the overlying strata. So the overlying strata is very much subjected to number of stresses, number of induced stresses by the blasting in the slicing operation, by the blasting in the deep layering. The heavy stresses are very much developed in the deep layering, in the slicing operation. It is there. The work along the dip and strike. It is there. The work along the dip is nothing but it is the development work, where the work is actually going there, where development work is nothing but the formation of the pillar is called the development work, just we discovered. And one more thing here, the drainage of different things, drainage of shafts in the inclines, and all the things are there. So that works is also coming under the development work, and we will discuss that. And after discussing the work done by the shearer. So this is the work done by the shearer. Yeah, this is the work done by the shearer. Many minings are there. Different types of minings are there. First is the conventional mining, where drilling, blasting, loading, transportation operations are there. And this is little mechanized by deploying the LSDs and SDLs, where loading by the coal fillers is removed and the coal is lifted by the LHDs, load haul dumper. The coal is lifted by side dish loader and dump over the conveyors. So this is the conventional mining is just changed to semi-mechanized mining. And one more mining is there, that is the blasting gallery method is there. Up to 30 meters of the roof coal, where 30 meters of the coal bed is removed at a blasting. So a lot of stresses are induced in the blasting. But a Borden pillar mining is applicable to and the 3 meters mining, 3 meters only. The height of the seam or thickness of the seam where the mining is allowed 3 meters. Suppose with a special permission up to 4.5 meters and the 5 meters we can go up to 5 meters with the special permission of the DCMS where the mining is done in the Borden pillar. But in the blasting gallery method, in the single college, the 20 meters thickness of the coal seams are there. The 23 meters thickness of the coal seams are removed. Actually, the galleries are developed just like similar to the Borden pillar. All the all the galleries are all the level galleries, not the raised galleries, not the deep galleries. All the level galleries are developed. Or in the level galleries, what they do, they lay the ring hole blasting pattern. They lay the ring hole blasting pattern around 33 blasting holes. The drill holes are drilled in a ring pattern, covering the total face of the total coal face in the development phases. So up to 20 meters, of the thickness, and with the help of jumbo drills, where we use the jumbo drills for laying the 20 meters above a coal drill as that we use in the conventional mining is where the drill rods 6 feet drill rod we use there. 6 feet drill rod generally less than just 2 meters, they are 1.8 meters something it is there. We use 6 feet drill rod in conventional mining, but in the blasting gallery methods, up to 20 meters, and the incline holes are very much drilled there. The incline holes definitely more than 20 meters. 20 meters into, I think it may be more than 25 meters also. The length of the hole may be. So the holes are drilled with jumbo drills, and different types of the drill bits are there. Suppose 6 feet drill, this one is fixed to the jumbo drill, and if that is not sufficient, again another 6 feet drill rod is fixed to the first drill rod. Like the similarly, the 25 more than 25 meters of length of the drill holes is drilled by the jumbo drills, but he is having a very big mast. Very big mast is there. The drill also is fixed to the mast, and the drill bit is fixed to the jumbo drill. With the help of this jumbo drill, so everything that and the drilling is done. And likewise, 33 holes are drilled. 33 holes are drilled in the blasting gallery method. So the total phase with having 33 holes, we put the there permitted explosive we use there. Generally, power gel we use the explosive there. Then we excavate, we blast out the face. So in the blasting, and we achieve more tonnage, more tonnage in a single blasting after 20 meters, of this thing, and we achieve the hundreds of tons there. But whereas in the single blasting, the Borden pillar, the development, there we achieve around 20 to 30 tons of the coal. There, more than 100 tons of the coal is achieved in a single blast. In general, maybe the 400 tons or the 500 tons is achieved by the blasting. In this one, in what we use in the blasting gallery method, that is there. So heavy stresses are developed because we are removing up to 30 meters, 20 meters to 30 meters thickness of the pole. We are removing where thickness of the pole is up to 30 meters, and 30 meters pole is lifted out. And heavy the heavy blastings are induced there. Heavy stresses are induced this type of blasting. Why? Because a very large chunk of the coal is the total mineral weight up to 30 meters is removed, and the total strata is subjected, and that is one here. And work by the shearer. Actually, the starting in the it is what is actually the face of the mine. Actually, the face of the mining slowly being converted into mechanized mining by deploying And many machinery, suppose the total phases, actually drilling, blasting, loading, transmission, all the phases are mechanized. All the phases are mechanized by the shearer. All the phases are mechanized by the shearer. Oh, there where we use the shearer, where we use the shearer. Hmm. Where we use a shearer. In the shearer, what is there actually in the longwall mining? And the gate roads are made, and the tailgate and main gate road is made, where those connected by the face. In the face, AF is installed. On the AFC, the shearer is installed, and the shearer is the cutting loader in the longwall mine, where shearer cuts the coal, and the coal is fallen. The coal is fallen, and the fallen coal is lifted by the AFC armored flexible conveyor, which transport the material from the coal face. The coal length of the coal face may be around 100 meters to 250 meters of the optimum length. So it carries from the face to the junction of the main gate. There, the stage loader is installed, and that shifts the material over to the gate belt conveyor. The gate belt conveyor, which is run in the main gate, main gate roadway. So the main gate roadway, which is run in the main gate roadway, where in the main gate roadway, the conveyor is the gate belt conveyor is installed there. So which transport the material from the phase to on this one, which transfer the frame from the phase to the discharging point, the load discharging point, where one more the conveyor is installed there, that transports the bunker point, from bunker point to the surface point. So this gate belt conveyor transport the material from this one, from the starting point of the main gate roadway to the bunker point, which may be around 250 meters to 500 meters. Optimum, this is 250 meters is the very optimum. So where the cutting loader, the cutting loader is a shearer. The cutter is a shearer we use in the lumber mine. So generally, we previously 20-30 years back, Singanakali used to have 320 tons the shearer. So now the range of the shearer has been very much increased, and 550 shearer was used. Now they are using 1100 HP shearers. But when you see the capacity of the loco, which is only the loco engine is 110. When the loco engine is passing by the side of platform, the vibration occur. We feel the vibration. But when the capacity of the shearer is 10 times more than this one, what we call 10 times more than the loco engine, that is 110 into 10, it becomes 1100 HP. So the capacity of the shearer is 1100 HP. So 1100 means it's very immense, very large mission, and it creates very big vibrations, larger vibrations. And while excavating the coal, a lot tons of coal, the tons of coal is excavated. The tons of coal is exploited by the shearer. But on the outside, the total strata is very much affected. The total strata is disturbed and destabilized and affected by running of the shearer, because the capacity of the shearer is very much high, very high shearer is there. So that is a larger scale, and the roof is disturbed. So we erected the power supports. Generally, the chalk shield supports are we use there. The capacity of the chalk shield support may be 1,200 tons, and so the supports we use there, because the outside area heavily disturbed. So, and the stresses induced by the shearer is very much immense, and to create the protected zone, high strength chalk shields. Generally, the chalk shield, the 200 tons capacity chalk shields we use there. So face length may be suppose 100 meter face length is there. So we use 100 meter, 100 chalk sheets there. When you see the 100 into this one 1200, around how much it becomes? It becomes very much high. When you see this one, 1200 into 100, so 100, 100, 1.2 lakhs, almost 1.2 lakh tons, 1.2 lakhs, and this is the tonnage, and this is the number of this one. And when you want to convert into cases, again it is multiplied by 1000, and that much protected zone is created by the erecting the chart sails. The chart sails and the latest revolutionized power supports, and which is very much useful, and they create and the protected zone in the this one in the mining in the area. So all these all the stresses are developed by the shear area, and in the mining, and other things also there in the mining. Other things, due to the driveways are the inclines and the shops, inclines and the driveways, the shops, inclines and roadways. Again, the stresses are developed while driving. The blasting is done, but while the blasting, generally the stresses are very much developed. These are the different stresses are developed. So the blasting, and so by these all the things, many stresses are developed. But when you see the this one, the stresses around a roadway, a small figure is suppose this is the excavation we made. This is the excavation we made, the coal excavation we made. Suppose this thing, these are the different layers of the strata, different layers of the strata. How it becomes? Immediately this one sagging is done. This one a little sagging is done. What is then? And this is called zone of bed separation, and this is called zone of sagging, and this one, and this is the lateral stresses, and this is the vertical stresses which are there. Uh, this is the where this is the coal block where the excavation is made here. So the strata over the excavation is affected. Actually, the P1 are the vertical stresses acting on it, and the P2 are the lateral stresses. The P1 is the vertical stresses, which are acting vertically downwards due to acceleration, due to gravity, and the P2 are the lateral stresses. The lateral stresses may be with this one, with the lithostatic lateral stresses are there, and the hydrostatic lateral stresses are by virtue of the rock itself, by virtue of the containing water, some type of stresses are there. So these two are, and one force is acting like this, the P2 force is acting like this, and this is acting like this, and the P1. P1 is the vertical forces which are acting this, and the P2 is acting. The resultant force, the resultant stress may be in the form of the diagonal. The resultant stresses are in the form of diagonal. So one type of diagonal is like this, other type of diagonal is like this. But when you see, suppose this is a zone of first appraisal. So one side, and this is the first diagonal and this is the second diagonal. But when you connect the diagonal, a arch is formed, and what we call this type of theory, the pressure arch theory. So one arch is one diagonal is there, another diagonal is there. But when you combine the diagonal, a simple arch is formed. So the stress is developed along the arch. So this is the excavation is made, and this is the different layers of the strata. And the strata, and the first zone is called zone of separation, zone of bed separation. Immediately it is very much affected, and in the strata in the zone of bed separation tends to fall down very immediately. Hence the supporting, very much supporting is needed, very much supporting needed immediately at this point. So for the freshly exposed roof, supporting is done, and with the help of wooden props, with the help of iron props, the supporting is done, because the zone 1 is a zone of bed separation, where a lot of the zone is very much at this side. And the second zone is the zone of sacking, where the layers of the strata bend down. The layers of the little sagging is done, but the break does not occur. But in the zone of Metzefer, the break occurs along the arch, along the serious distability is done in the zone 1, where the sagging occurs, little sagging occurs to the bed. The layers of the bed have a tendency of little sagging, and little sagging is done to the beds which are there in the second zone. So and little destabilization is done, is occurred here. But when you see another arch is formed, and the another arch is formed, third one, this one, where much larger pressure is built up. Why? Because when you see the P1 is acting downwards, and the P2 is acting this one, the resultant forces are diagonal forces created. But when you combine the diagonal forces, the arch is formed. So the pressure is acting along all the arches. So in the corners, the abutment pressure is created. The abutmentic pressure is created. So this is the zone 3 is heavily created, what we can, this is the pressure zone, where with the diagonal, the resultant diagonal pressures are developed. So by the resultant diagonal, when you connect the resultant diagonal stresses, arch is formed. So along the arch, the pressure is acting. So at the corners, the abutment pressure is created, and the corners the corner fails down. So we have to concentrate the corners of the excavation. So that is the zone 3. But when you see the flooring is the zone 4, the floor is the floor is heaved up. The floor comes up when this is the mineral bed is the mineral bed. When the mineral bed is subjected to this one, and the folding occurs. Due to the folding, the floor of the mineral bed comes up. And the floor heaves up. The heaving is done. This is the zone. Here also, there's some kind of stresses are very much developed. The fifth zone is the zone of stress release. The pillar here, the pillars are this one, and this side the pillars are the pillar bulges, where the bulging is done. So the pillar is subjected to different stresses. The pillar bulges. So while bulging, the stresses are releasing, and this is the zone of pillar bulging, and due to the stresses and the pillar bulges. So here, what we call, this is the the pressure distribution around the excavation, around the opening of a roadway. So here, when the excavation made, when the opening is made, and the strata is converted into 5 zones. First one is the zone of bed suppression. The arch is formed like this, and second is zone of sagging, where sagging is there, and third one is the high pressure area buildup is there. A lot of pressure is there, where the apartment pressure is there. The corners will fail down, so a lot of care has to be taken. And the fourth one is zone of the floor heaving, and the floor is subjected to the stresses, and the floor comes up. This is there. And the fifth one is the pillar is subject to the stresses, and the pillar bulges. So this is about the stress around the roadway opening, and we discussed the induced stresses in the underground, in the open cast mine. So these are the different induced stresses which are developed. Thank you.